Good morning, everyone. It's me again. Uh, First of all, I know I said I'm going to release only one video a week, and this is my second one of the week. It's also only my second video ever, but it was released that NASA has given the thumbs up to launch the Parker Solar Probe tomorrow. Now, for the listeners that don't know about the Parker Solar Probe, it's a satellite um, probe, whatever, that is going to go into the sun. It's our first ever official man-made object touching the sun. It won't reach the surface of the sun. It will, but it will go into the sun's atmosphere and be at a closest approach of about 4 million kilometers to the sun's surface. But even that brutally heat, it's impressive they actually made this probe. So the idea behind the probe is to understand and trace out the energy and heat, how it travels within the sun. Now, I'm no expert on that, it's not my field of study, but this is important for our planet. The solar winds, the heat distribution of the sun, it creates space weather. We are affected by it. Our satellites have a hard time if there's a lot of solar flares at a certain time. Uh, so we need to know how the sun works. Furthermore, we need to know how the energy flow works. That's why we have satellites outside that can measure this flow. But if we don't know how it originated, we are still a bit lost. We have good predictions, and the work being done on solar physics are extremely good. It's almost better than any astrophysics, since we in astrophysics we only have telescopes that can get a few data. They in solar physics actually have satellites going around the sun, going around the planet, going to other planets, see uh, how the solar wind and magnetic field currents change. So they have quite extremely accurate predictions, but you still need how it looks inside the sun before you can be sure 100% that your models are taking into account the correct assumptions, all of that. So, why is this important? I mean, the sun is always up there. Yes, it's always up there, but the sun has a active and non-active period. At the current moment, the sun is actually non-active, so almost no solar flares, almost no CMEs. There might be today one, I'm not sure, but it's relatively low, uh, which means the magnetic field um, and solar winds are weaker as far as I remember. No, especially the magnetic field, it's much more stable at the moment, if you can say. This has a complicated problem, or it gives a problem for us, because the magnetic field and the solar winds, they create the heliosphere, which is like the pocket within all of the planets, where we get the sun is our main source, and we are within his pocket or her pocket, if you want to apply gender. But particles come from outside our universe as well, and that particles are highly energetic. So astrophysics, they love that particles because they give a lot of information about black holes, about neutron stars, whatever. So but they are dangerous for us, so they come in, and the heliosphere, if it's strong, keeps them out. So it's like a inverse. If the sun is weak, more particles can come in towards Earth. If the sun is active, these particles can come in, but then you have solar flares and CMEs, which are not too good for our satellites. So if we can understand how to predict these stuff more, like I said, we have predicted. We can say I we can say which years will be inactive. But if we can predict more accurate, we'll maybe be able to find better shielding for our satellites, for even our electrical currents in the Earth's atmosphere. Your cell phone, your the entire electrical grid, everything is dependent on this. So for this Parker Solar Probe, it's actually very important for us to get our first satellite within the sun to actually see from an inside view how it works. Now, another awesome thing, which I don't know if everyone thinks it's awesome, but for me it was awesome. A few months ago, NASA released a link so you can send in your name. Like you book a ticket for your name, and they put all of the names on a small memory card inside the Parker Solar Probe. So I think they had bit over 1 million names the last time I saw, but it could have changed. It what I saw about 2 months ago, so it might be much more now. That names of people on this earth that are partaking in the first step of understanding our sun more, because all of human history we saw it from the outside, and now finally we have they have the technology, made the technology to actually go with something towards the sun, go into it, handle that intense heat, and tell us outsiders how it looks, the data, how energy moves. It's just incredible that the people actually figured it out. So good luck to NASA for them with the launch tomorrow. It will still take a few months, most probably like a year or something. I'm not quite sure the travel time at this moment. Upgrade of boosters, upgrade um, of where we are in the closest approach. So lots of things have an effect on the travel time. So I'm not sure what's the actual travel time towards the sun at the moment, but it is a long trip, so it will still take a few months before the probe actually gets there. Oh, the reason why it's called the Parker Solar Probe is named after the guy Parker, I think that's its surname. He was the one to write down the Parker transport theory, the Parker equation, which explains how these particles move. So a good remembrance of the pioneers in this field. Um, so yeah, good luck with them. The rocket they are going to use is, let me just get a full name, United Launch Alliance Delta 4 Heavy Rocket. Yeah, so that's the official name of the rocket they are going to use. So good luck again. And if you haven't subscribed yet, hit the subscribe button, leave a like if you like the video, and if you want to be notified whenever I put a video on, push the click on the bell icon, then it will notify you. Thank you for listening.